What's up guys, welcome back to another video, and in this video we are going to talk about the prime numbers, how we can check if a number is prime or not using Python 3. So what are prime numbers? The number that can only be divided with 1 and the number itself to get a remainder 0, means a number of factors 1 and 5, 1 and the number itself is called a prime number. For example, if we take a look at this number 5, then 5 can only be divided with 1 and the 5 only to get 0 as a remainder. So 5 is a prime number. But if we talk about 6, then 6 can be divided with multiple numbers rather than 1 and 6 itself. So it can be divided with 2 and 3 as well to get remainder 0. So 6 we cannot call 6 is a prime number. So now how we can code it? So let's go back to the Visual Studio Code to show you the example. So the concept is we will take the number take the number inside of a variable and try to divide it with all the numbers below it, and if we are getting a remainder as 0, then we will say that this number is not prime. So let's do that. First of all, we need to take the number from the user. So let's use the input function. Let's type enter the number, and then the input gives us a string format, so we need to convert it to integer using the int function. So let's do that. And now primarily we will say that this number is prime. So we will take a boolean variable, and that is going to help us in the looping. So is not prime equal to false, means the number we are taking is we are just assuming that this number is prime, so that is why we are taking that is not prime equal to false. Now we need to run a for loop to check the divisibilities. So we will run for I in range, and 1, the number 1 can divide every number with remainder 0, so we will not take 1, we will start the loop from 2, and we need to go up to the number -1, means if we are checking the number 5, then we need to divide it with 2, 3 and 4. So we will go up to the number -1. So here we can pass num, because the range function the range function is exclusive, because if we pass the stop value, it will go up to the stop value -1. So if you are passing here say 6, then it will go up to 5. So that is why I am passing num. Now we need to check the divisibility. So what we can do, so we will check using the if else condition. If the number and modulus give us the remainder, so modulus I equal to 0, means we are getting the remainder as 0, then we will set that is not prime equal to true, because if we are getting 0 as remainder, then the number will not be prime. So that is why we are setting this boolean value to true. Now once we are getting this, that the number is not prime, we don't need to run the loop again and again. So then we will break the loop, and we can use the break statement here. We will start from number 2 and we will go up to the number -1, and if we are getting 0 as remainder while dividing all the numbers below it, and then we will say that is not prime equal to 2. Now we need another condition checking operator, where we will say that if is not prime equal to true, then is not prime equal to true, then we will print that the number is not prime. So we will print if that number is not prime. Else what we can print, else we will print that the number is prime. Else print. Now let us check it by running. So I will click on run, and it is asking for the input. So let us give it input, let's say 32, and you can see that number is not prime. Now let's check with 5. So if I press 5, then you can see that number is prime. Now let's make it now there is an optimization for this code. Now let me go back to the slide, and here if you see that the number can, if you are dividing a number, then the expectation of getting 0 by dividing it is, if we divide it with up to the number divided by 2. So for example, if we divide 5, if we divide 10 with 5, then we will get 0, but no other number greater than 5 can give us 0 as remainder. So if we divide it with 6 or 7, 8, 9, whatever, that will not going to give us 0. For a number, we can divide it with the number divided by 2. For say for example, if we divide it 18, then what is the half? Then half is 9. So any number greater than 9 cannot give us remainder 0. So that is the optimization. So we don't need to run the loop up to the number. We can check up to the number divided by 2 itself, and this double slash means we are getting the floor value. I think you know. If you don't know, check out my one of the videos that I have using these arithmetic operators, and let us run the code, and it will going to give us the same output, but it is the optimized one. Now let me give it one more input, and you can see that it is giving us the correct output. Now the most optimized way of getting a number is prime or not is the square root of num, because let's say for example we are checking that 16 is prime or not. Let me make it full screen, and then if we divide it with 8, then we are getting 0. If we can divide 16 with 4, then we are also getting 0, and if you are getting 0, then the number will not be prime, right? So in fewer iteration of the loop, we are getting that the number is not prime. So in less number of iterations, we are getting the output. So that is the optimized one, right? So what we can do, we can find the square root of this number and find the remainder. If the remainder is 0, then we will not be iterating the loop. We can simply get out of this loop and print that number is prime or not. So most optimized code is, don't need to go up to the number, up to the half of the number. What else we can do, we can go up to the square root of the number. So to use the square root, we need to import the math function in Python. So let's import that, import math, and we can go up to the square root. Sqrt function gives us the square root of the number. Now let us run the code. Of course this is going to give us the right output, but what is the problem? Port object cannot be interpreted as integer. So this gives us a float object. We need to convert it to integer using the int function. So let's do that, and let me save it and run it again. Now let's give 43, and you can see that 43 is prime. Now let's give one more number that is not prime, 56, and you can see that the number is not prime. Now let's make it more dynamic. This is kind of looking weird. We need to print the number itself in the output also. So we can format the print using the if and a curly braces inside of which a number, and we don't need this number anymore. Let me remove it, and this is the optimized code to check a number is prime or not. So this is the final output. If we check 5 is prime or not, you can see that the output is giving dynamically that 5 is prime. And let's check 6, 56, no problem. So you can see that 56 not prime. So this is how we can check using Python if a number is prime or not. I think you got the concept, what the algorithm of finding a number is prime or not, and how to optimize the code to check if a number is prime or not. So that is all for this video, and if you really enjoyed and learned something from this video, please hit like and subscribe the channel also if you are new here. So thanks for watching. We'll see you in the next video.